I see I missed some questions again. All right, we need to find the intercepts. Remember, we're looking at the x-axis and the y-axis. When I look at the x-axis, there's only an open circle. This is not an intercept, because that open circle means that x is not equal to any number there. So the open circles are not intercepts. In fact, we only have one intercept here. We have a y-intercept where y equals 2. Now, I'm not sure if Pearson asks you to write y equals 2, or if they're looking for an ordered pair. X is 0, y is 2. Read carefully and check your homework. That's a place where you can decide what type of answer needs to be inputted. We should also talk about these jumps. Is there a jump in the graph? There is. A jump is when you lift your pencil. Oops, that's not an I. When I'm graphing this, it's not like a polynomial function where, oh, we haven't done those yet, have we? Where the graph is smooth and you never lift your pencil. When I'm graphing this one, you can quite clearly see that I've come down to 0, had to lift my pencil, and then had to lift it again. So that tells me that there is a jump in the graph. And the jump occurs where x is equal to 0. Right? It's occurring right here along this axis where x is equal to 0. That tells me that the graph is discontinuous at x equals 0. So you're looking for that place on the graph where your circles are. If you have open and closed circles in a vertical line, just like we do here, then you have a jump, and then your graph is discontinuous. A continuous graph doesn't ever require that you lift your pencil. It just smoothly keeps going up and down, or only up, or only down. Those are all continuous. They don't break anywhere. All right, let's go on to the next question here. Sketch a graph of the given function. We need to graph each of the pieces. Now, you might remember that we've found these endpoints already, but it's probably good practice to find them again. Remember, we use the domain restrictions to find the endpoints. Find the endpoints for the first piece. You found the f of -3. We see that x is equal, so it needs a closed circle. You found the f of 1. That needed an open circle. So at -3, 7, we have a closed circle. At 1, -1, we have an open circle. And we see that this is a linear equation. So we know that this is a straight line connecting these 2 points. I also saw that it had a y-intercept at +1. There it is. Perfect. Pause your video and find the endpoint for the second piece. You found the f of 1 that equals -3. Remember, this is a single point on the graph because we just want the graph where x is equal to 1, not where x is greater than 1 or less than 1, just equals to 1. And of course, we have a closed circle there because it is equals. Find the endpoints and graph the last piece. The endpoint for this piece, you found the f of 1. You're going to use an open circle at 1, 1. And this is the graph greater than 1, so we're going to x equals 2 and 3. And we know if we substitute x equals 2, we're going to be at 4. If we substitute 3, we'll be at 9. This is a parabola, not a straight line. So we have these 3 pieces that need to be put onto one graph. So why don't you take those now and put them all together on one XY plane. So here are all of the pieces of our graph put together in one plane. We see our first piece, the linear function from -3 to 1. We see our second piece, a single point at 1, -3. And then we see our third piece, the parabola that starts at x equals 1. Can you see the domain for this function? We see that its lowest value on the x-axis is here at -3, and then it continues to positive infinity. We have a square or closed bracket at -3 because we have a closed circle on -3. If we go back and look at our original piecewise defined function, we can actually see the domain in the restrictions. We see that x has to be greater than or equal to -3. There's our lowest value. And greater than -1, meaning it's continuing to positive infinity. So you can always look at the restrictions and find the domain there. The range for this question is a little bit difficult. Remember that the range is looking at the y values. So we're looking along the y-axis. And we see this point here at -3, but then there's nothing here. So first of all, we have a single point at -3. It's not an interval. It's just the set of that one number. Remember that the brace brackets indicate we have a set. And then it's a union with the remaining set. Well, I see then here at -1, we have an open circle. So that means I'm going to have an open bracket at -1. And everywhere else along the y-axis, I have a graph. Even when I get to here, I know it stops. But if I look over here, it continues up to positive infinity. Again, finding the range can be difficult. You may want to look in your e-text at the practice questions there, or find those questions in the homework of Pearson and try them again and again until you get used to finding the range. For the range, you really do have to look at the graph and determine what it is. Next, we want to find the intercepts. Now, when I look at the graph, I can see that there are 2 intercepts. There's an intercept here, and that one's pretty easy to see. There's also an intercept here, a little bit more difficult, and we don't want to guess. So what do we do? Well, first of all, I hope you remember that that piece of the function where both intercepts are found is the first piece. So we need to go back to that equation. The equation for the first piece is this one here. Oops, the f of x equals -2x plus 1. So let's look at that first piece. F of x equals -2x plus 1. I see there is both an x-intercept and a y-intercept on that piece. To find the x-intercept, we have to let y equal 0. So we have 0 equals -2x plus 1. I see I have an intercept at x equals 1/2. And that does really look like a half there. So an x-intercept at x equals 1/2, or if it asks for an ordered pair, 1/2, 0. To find my x-intercept, my y-intercept, we're going to let x equal 0. Of course, it's at 1. We knew that. So when you're finding the intercepts, you need to look at your graph and determine which equation you're going to need to use to find your intercepts. Is there a jump in this graph? Yeah, there is. We have a jump right here. There's our stack of circles. Where does it occur? At x equals 1. So there is a jump where x is 1. This graph is discontinuous at x equals 1.